Okay guys, today we have section 1, or part 1 of section 4.4, complex numbers involving I, or imaginary numbers here. Okay, imaginary numbers come from the square root of -1. Okay, if you were to normally type that into your calculator, and even now if you type that into your calculator, you will get an error. But okay, we still need to do square root of -1 for some things. So, mathematicians have come up with the imaginary numbers. And the imaginary numbers all stem from the square root of -1. The square root of -1 is now I for imaginary. Okay? So we'll have some problems here dealing with the powers of I. If I have I to the first power, there's only one of them, it's just I. I to the second power, okay, is going to be -1. If the square root of -1 is I squared should take me back to -1. That's where the whole basis of I came from. Okay, what about I to the third? That's I times I times I. Okay, if I put parentheses around two of them, I know that two i's multiplied together equals -1. So this is -1 times I, which is just -I. And I to the fourth. So there's four i's. Put parentheses around each pair of two. We'll get -1 times -1, which is +1. So you can see we've gone from I to -1 to -I to +1. If I had I to the fifth, okay, that'd be four i's, which I know is 1, times one lonely I out there. 1 times I is I. And now you've seen we come full circle here. I, -1, -I, +1, and back to I. Okay, so really we're looking at those top four. I to the first, second, third, fourth. Okay? If we had to do a power of, like, let's say I to the 33rd power. Okay, these power of 4s are very important, or the factor of, or multiples of 4. So what I would do is I would think, what's a multiple of 4 that either equals this power or is really close to it but under it? Okay, so 33 is not a multiple of 4, but 32 is. Okay, and because it's a multiple of 4, all those multiples of 4 will equal 1. So there's going to be a bunch of 1s down here. And then there'd just be 1 left over, right? 32. I used the 32 to get all these 1s. And then there'd be the 33rd I. So it's 1 times 1 times 1 times 1 times 1 times I, which is just I. Okay, if that works for you, that's great. If not, here's another method. And I use this method with really large numbers, like if we had I to the 312th. Okay? I to the 312th. I do not know real quickly if that's divisible by 4 or not, or what would be a multiple of 4 close to that. Okay? But if you just divide whatever the power is, divide by 4, you look at the decimal. Oh, and this one doesn't have one. It's 78 exactly. Okay? So if our decimal would have been 0.25, that means we would have had 1/4 left over to the power of 1. So that would be an I. If I would have had a 0.5, that's 2/4 left over, 2 out of 4, or 2. So then we would have had a -1. 0.75 would land me here. And 0.0, or a whole number, gets me to an I to the 4th, which is 1. So 312 divided by 4 was 78.0, no decimal. So this would just be a 1. What if I had I to the 313th? Okay, I'd type that in. It's going to be 78.25. My decimal would have been 0.25. I look up here. It's I to the 1st. Okay, so that's one way to do those problems. Another set of problems you're going to need to know. Alright, reducing some square roots. Okay, square root of negative 28. So we're going to do this just like we normally would. Okay, a perfect square that goes into 28 would be 4. And my other number with that would be 7. So I like to put the negative on the perfect square, so negative 4. Square root of negative 4 is going to be 2i. And we'll just have a radical 7 with it. Okay? So do the square root of 4, gets me the 2. The negative part is where the I comes from. And then we have the square root of 7. Okay, another good one here. Square root of negative 125. We're going to break this apart. 25 and 5. 25 is the perfect square. I'll put my negative on that one. Okay, I can do this one. Square root of 25 is 5. The negative makes it an I. And then we'll have that 5 there. Alright, that's it for this first part, and we'll have the second part up shortly.